So thank you very much, Martin, for this kind introduction, and I'm really glad to be here and to have the opportunity to talk about some ideas on interactive real-time simulations and how they could be framed. Yeah, I'm also looking forward very much to the discussion afterwards. I'm talking a little bit long, about an hour, so I would like to apologize for that, but I'd like to show you two videos. Generally, I am interested in phenomena which exhibit features that were simply not possible before the era of the computer. Coming from a research context that is focusing on visual imagery, I investigate computer simulations providing real-time interactivity as a segment of the newest image production. So this is the way how I look at the computer simulations. Having chosen such a selection criterion, it seems reasonable to pursue questions regarding the characteristics and the preconditions of such a visual imagery, most often accompanied by sound, of course, and also by haptic feedback. So such a visual imagery or a sensuous configuration that can react to the user input more or less instantaneously at any time. It also means being grouped among the theoreticians of discontinuity, those who propagate innovation and who focus on the new. However, as you will see, my presentation basically consists of a comparison between two highly influential paradigms of representation. I draw some parallels from the simulation to the widely known linear perspective, thus I am also in part a theoretician of continuity. To give you a short overview, I propose seeing computer simulations as being preformed by a kind of perspectiviation on a general level. I further argue that this system's perspective can be conceived as a kind of constructive cultural medium that influences the outcome it facilitates to a certain degree. We will see that there are further levels of forming, contributing to the result and calling for different competences in order to design such serious games as those we're going to see today. At the beginning of my presentation, I'd like to show you three simulations. The first example comes from Ursula Damm, a German artist currently teaching in Weimar. Her two-part installation Double Helix Swing investigates the swarms of midges that can be found on the banks of lakes and lagoons. Each swarm develops its own speed and rhythm and forms itself into an axis, which is circled by the midges in both directions, thus forming a flying double helix. Damm developed a special setup I'm trying to show you here to attract the swarms and to film them outdoors. This is one part of the work. Indoors, we see the video of the midges projected onto the wall. It forms the background for several computer-generated layers, and here I made a diagram. So we have the recorded video. Here, the recorded video, then the traces that are computer processed to be made visible a little bit longer. Then we have the layer of the artificial life and the mouse for the user input. So there are several superimposed layers of imagery from recorded and calculated elements. The spatial configuration is quite complex because it combines a video, and a video is always a segment with a whole because the virtual population is presented in its entirety. So here I show you a visually simple predator-prey scenario from the University of Karlsruhe to show you what that means. So if an agent is, if an agent is leaving here on the right side, it immediately appears on the left. So we should imagine this square as a projection of a surface without border, like a sphere. But in my view, these spatial decisions, or the fact that the developer here, for example, used the main characters of South Park in order to represent the single agents, are not part of what a simulation defines. I would like to focus your attention to the computer-generated virtual population on the artificial life. These creatures move, mate, and are capable of evolving. According to the Darwinist principle of the survival of the fittest, those adapting best are successful in tracking the computer-processed movements of the real insects. The behavior of the virtual creatures depends, therefore, on the real means recorded environment, but it is also conditioned internally by their genetic code. A small computer terminal is set up in front of the indoor projection. Here, the spectator, or better the spect actor, have the possibility to manipulate the gene code of the creatures. I show you now a video, less than 3 minutes. The video is edited. I inserted some cuts and I emphasized those cuts with additional black frames in order to raise the awareness that the simulations do not have these cuts, but rather consist of an uninterrupted series of events and feature a situation. So in principle it would go on and on. However, of course, in artificial life situations there could be the situation that a species dies out, and so in this case no related process is apparent anymore. Let's show you the video. This is a small terminal where you can interact. Here you see that the system cannot calculate that anymore, really. The second work I would like to introduce to you is a computer-generated environment used in psychotherapy to treat arachnophobics. You can experience this scenario with a head-mounted display in the therapy room or download it onto your computer if you have the computer game Max Payne installed. As common in systematic desensitization, these graduated exposure therapies, there are various degrees of difficulty the patient has to cope with. So, level 1, here you encounter, well, several rooms. They are quite clean. There are some terrariums where you see 1 or 2 spiders in there, but they are behind the glass, so the glass is intact. There might be a spider net, but not inhabited. Then level 2. You will encounter here additional posters, maybe first something very diagrammatic like that here, but if you go to the living room you have really some big posters, and behind the TV set they're quite three-dimensional, spiders, the most weird depiction is of course this, where you have the spiders in the eye. And the next step, a spider, small spider, not moving in the room without the glass. Level 3. So I would recommend everybody to leave the room. Here you encounter some nice specimen with some spiders really reaching also the height of the knee of the avatar, which in the male version is of course Max Payne. So the patient navigates the avatar in a first-person view through the rooms and can try to escape by running and jumping, jumping like Max Payne, or eliminate the spiders with a newspaper that can be found on the kitchen table, and the efficacy of the newspaper weapon is really tremendous, damaging even the floor. I don't know if you see that here. It's like shooting. The third work is a surgical simulator commercially distributed by the Israeli enterprise Symbionics. Uro refers to urology, of course, the medical specialty that focuses on the urinary tracts. Uro Mentor is a hands-on training and practice opportunity for diagnostic and therapeutic procedures for medical staff. They learn how to execute an intervention in a completely computer-generated virtual world. This is a way to avoid harming living patients as guinea pigs. So trainees move on from more introductory exercises to a variety of virtual patient cases, each with their own anatomy and pathologies. On the website of the enterprise, one reads that these images are presented on a true-to-life system that provides a look and feel that are so close to reality that at times it may be hard to distinguish the difference. Here, this means that the real interventions on patients also function such that a camera is introduced into the body and the doctor is not looking at the patient but is looking at a monitor showing the video, camera image. In this mediated situation, the coordination and the orientation of endoscopic camera tools are quite complex. Here you have the interface, here are the surgical tools that you are inserting, and here is the scene where you're looking at. In a minute I'm going to show you my own experiences uncut and in full length. With this example I would like you to pay attention to the scenes with the endo camera and see whether it is true what I said earlier, namely that the simulations, that what I said about the simulations, namely that they are an uninterrupted flow of events. We now see my attempt to remove the kidney stones. I can normally barely stand showing the video, not only because it is highly embarrassing, so you see and hear my conversation with the medical doctor, and I'm speaking in slow motion because I have to concentrate so much on the things that I am trying to do. But also because I think that you very quickly understand what's at stake in the situation. And so I have the impression that the scene gets very quickly boring for you. However, while being involved, the situation is not boring at all. And it is not about winning a time-critical game, because the actual interventions may last several hours. A further aspect of showing it in full length is also to demonstrate that a certain monotony and uniformity can definitely be a feature of simulations, as you already experienced with the first example, the double helix swing. So the video is 11 minutes long. I added some subtitles so that all of you can follow, but I fear that the subtitles might be also distracting. If so, please stop reading them and keep watching. Can you hear that? Not so good. Original is already bad.
Ja, das ist ein Punkt.
Okay, muss ich nochmal.
Ganz gut ist, wenn man quasi mit einer Hand so ein bisschen zu hält, weil
Was? Wie mache ich das? Kannst du das machen? Nein, das weiß ich nicht.
Und das sagt aber eben, dass es visuell ist.
Ja.
Das ist jetzt einfach, dass es vor mir läuft.
Genau, genau.
Die Blase, die ist jetzt voll Wasser.
Genau. Das können wir auch noch lernen. Kamera nimmt vorne quasi eine Wand anlegt, das natürlich gar nicht mehr. Auch die näher mal ran, das ist schon nicht perfoриert. Nicht so ganz da, wo es in echt ist. Normalerweise ist es so, dass man den halt da irgendwie rein. Das geht dann auch vorbei. Kann man mal röntgen, möchte er das rechte. Das ist gut vorstellen. Genau, ich schiebe raus, das mal rein. Der Patient kann man in den Schrank schauen. Also Einheitsbewegung, Minuscode und Beta und Minus. Meistens einfach die Forschung, die schon klar ist, das kann man immer total leicht. Mal röntgen,
Und die Entfernung spricht die auch ungefähr?
Ja, etwa. Ich fahre mal kurz den Röntgen auf. Schwester, die halt gerade so ein bisschen auf das Ganze gefahren und so.
Okay.
Gut, okay.
Und normalerweise hat man die beiden Ansichten als zwei verschiedene Monitore.
Ja, normal haben wir, das ist der Monitor und das Röntgen hängt bei uns so oben daneben irgendwo.
Okay. Das kann ich, glaube ich, nicht jetzt irgendwie variieren oder nicht?
Ja, wenn du ein bisschen zurück ist, das ist halt, also du klebst du quasi an der Wand gerade. Und wenn man nicht mehr sieht, dann immer ein bisschen zurücknehmen. Genau, nochmal. Man muss hinten mal so ein bisschen hin und her gucken, dass man es nun wieder nicht. Da sind wir genau. Genau, nur in ihrem Becken. Treppenhaus, das sind wir ja oben. Gut. So, jetzt gehen wir Kontrast weg, also das ist schon mehr, Effekt, wenn wir die Kälte ab. Immer wieder Röntgen, also wie das kein Patient, den kann man ruhig bestrahlen.
Ganz oben. Zu weit weggehen davon. Macht er gar nicht. Aber ist real ist ja nicht so.
Ja, doch schon. Man soll nicht allzu viel abschließen.
Aber es ist nicht so, dass das Gerät den Anschluss zeigt, oder?
Nee, das stimmt nicht. Das Weichenstein, das Hartestein, also das ist alles.
So if I ask you now whether it was true that the endochem situation was shown a continuous flow, then you would have to say no. Each time I remained stuck in the tissue, the static image was superimposed, in which I could neither see my instrument nor any bodily reaction. Namely here, such insertions are typical for cases in which the effects of a simulated action cannot or should not be shown. The upper row represents 3 consecutive steps in a movement towards the tissue, and as the camera and the light source attached to it approach the membrane, the structures get bigger and the scene gets brighter. However, if one touches the tissue with the camera, we would expect to get a dark impression. Instead, we get a bright but static image, one chosen out of a repertoire of 5, and here I show you 2 of them. What I wanted to show you here is that I am rotating the endoscope. You see that because of the peak. Normally, with the rotation, the scenery would have to rotate, but this is here not the case anymore. The borders of the dynamics are shown also visually. We will see later that the relationship between the simulation and the visual imagery is not an evident one. Modeling every bodily consequence of a perforation of a urinary bladder is immensely complicated and costly. It could quickly become too intricate to be calculable. Although it is the declared aim of such simulators to prepare the future surgeons properly for real interventions, it is not currently possible to duplicate, of course, the whole spectrum of reality. Most of the simulations, also those of the 3rd generation, only have a flat scenario. By this I mean that there are 3 or 4 consecutive steps and effects of an action that can be considered, but not more, because with each decision in an interaction, several resulting situations have to be foreseen in principle, and with each step the number of scenarios grows exponentially. This quickly becomes too much to program. In a certain sense, the introduced static images show something outside of the simulation as such. They are some kind of stop signals revealing the borders or the horizon of the simulation. Or to say it in the words of Alexander Galloway, presenting these static images is a non-diegetic machine act. Such stop signs can be found as in various applications in different versions. Here you see, for example, a part-task trainer for knee surgery, which was developed at the University of Sheffield. The stills show the interior of the knee, where in this case a free-floating particle is to be removed. But as soon as the endoscopic probe, the probe, not the camera, collides with the tissue, that is a collision, of course, that should be avoided. This triggers this yellow out, telling us that we are in the fat tissue, or the red out, telling us that we are in the flesh. So, in the first example, we saw a society of creatures. In the second, we were on the level of individuals, and in the third, we moved to the level of body parts or organs. Looking at the broad range of simulations, one could ask why they deserve the same name. Maybe you would think, okay, simulations are a wild field like our panel paintings too. How should we find a commonality that is still meaningful? Whoever thinks like this is, in my view, already more or less on the right track. It is actually not painting that will be our point of comparison to simulation, but another medium which underlies the works. So why do I say that media underlie the works? Couldn't one simply say that artists or developers use media, or these image worlds are made with media? In order to explain the underlying of layers of design, I refer to the German art historian Gottfried Böhm, who himself relies on the sociologist and systems theoretician Niklas Luhmann. Luhmann developed an anti-substantialist, observer-dependent conception of medium. In his holistic theory building, everything can be described as being loosely coupled, and that allows for a specification that is a strict coupling, can be conceived as a medium. The medium as such is not or cannot be seen directly, but only by the way of its concretization, and that is by the way of the strict coupling, and that is by a form. Building upon this idea, and for the domain of the visual arts, Böhm differentiates at least 3 kinds of medium. Media as materials can be natural materials, but also refined ones, as for example pulverized color pigments. They are somehow exceptions as they are directly visible. Sure, the undercoat may disappear under the next layers of paint, but in principle these pigments, for example, can be addressed by the eye. But something like drawing, etching or painting as such are coined a little bit more in cultural terms, and they too can be called media because thereby it is not meant an individual drawing. Understood like this, media on this level differ from discrete things. The next 2 types of media are also not directly visible anymore. They are conventions and as such a kind of order. This is a set of rules. These rules are not explicitly, visibly specified, but applied and followed. If, in a kind of reverse engineering, we interrogate works about these typical features, we may be able to determine these underlying orders. If we look at images from a distant point of view, and here distant point of view might be symbolized by the Google search result, where I looked for still life or vanitas still life, we see features that they have in common. The collective qualities results from the fact that a specific mediality with specific means is formed according to a certain manner and choice of subject. In this context, the notion of genre has been established. Böhm defines image genres as ensembles of properties. Art historians speak of a hierarchic order of genres as soon as these iconic modalities have consolidated into a typology. The main categories can be then classified into subcategories, etc. In any case, it is clear, writes Böhm, that the genres aren't isolated or even accidental modes of expression, but they represent a common order. This order affects the images and their configuration even down to the details. In it, a certain worldview is reflected. This order contains criteria of legitimation and controls the range of what can be depicted at all. End of quote. By the way, in an analogous argumentation, the game designer Ian Bogost speaks of the possibility space, and he discusses examples from poetry. In my view, changes with the most serious consequences are the ones that are based on a procedure or a constructive method. The most prominent example is the linear perspectival construction that was invented, of course, not only, but also by the Italian architect Filippo Brunelleschi in 1425, and which a few years later was described in principle by the artist and theoretician Leone Battista Alberti. Normally we discuss the perspectival construction in terms of images. But if we follow Luhmann's idea that a medium facilitates forms being images, we again have to be careful and to separate images and media. It is an important step to advance from an ensemble of images and its shared properties to a single image. All qualities extracted from the image genres determine a single image to a certain degree, but there still remains a broad range of individual decisions taken by the artist, even if she integrates all rules and modes of expression prescribed by the medium as genre or by the medium as construction method. According to Böhm, media are prescriptions or technologies used to fabricate images. They condition images. Here I show you drawings clarifying the distance point procedure as construction principle of the linear perspective. It provides a solution for linking the vanishing point of the horizon with the eye point of the observer. In this way, an apparent continuity between the real and the depicted world is created, and I read this excerpt. First of all, the mathematical central perspective is a method that facilitates images without being an image itself. It represents a medium of an entirely new kind. Therefore, the perspective as method and medium and a perspectively constructed image indicate different issues. How and whereby can we identify the difference? Here we see again the construction principle, and besides it, two clearly didactic examples of use. The constructive method of the linear perspective is not meant to lead to a specific image, but rather it constitutes a possibility of organizing the elements on a plane, a possibility that is suitable for a lot of representational tasks. Additionally, the mediality of linear perspective is relatively independent of specific material substrata. Admittedly, it should be a plane or a curvature that can be handled mathematically. The mathematical handling of this procedure does not determine if its execution happens with oil on canvas or with chalk on paper. By choosing the linear perspective, one has not automatically opted for the material, but for the construction medium, a set of mathematical rules. In principle, these rules allow for verifying the condition of appearance of all visible things on Earth and for representing them accordingly. In this way, the depicted things lose many of their natural characteristics. They are treated like dimensional constructs of surfaces that can be aligned in a plausible way. The central perspective is a cognitive procedure that allows ignoring some features of the world in order to assemble and standardize the visible entities as constructible bodies. On this slide, I have assembled 3 different applications. As soon as we are sensitized to paying attention to slanting lines along architectonic linear slopes, and that the examples together may exhibit a certain order, we then soon recognize the shared construction logic as part of their composition. We see common features and how the space is organized, even if the single images are clearly different. So this excursion into linear perspective served to illustrate the extent to which one can look after an underlying medium. What about these examples? I am convinced that we can find also such a construction medium in real-time simulations. In analogy to the construction diagram all'Alberti, we can, for example, examine the so-called flowcharts. On the left, we see a typical way in which computer programs are sketched. We see lines, arrows, boxes. According to this logic, in executing the structure, a given situation is consulted again and again, and in a way that the decisions can be answered in a binary mode. Yes and no, plus and minus. The system replies what is the case, it delivers feedback, it determines the agent's behavior, for example, which due to his program disposition is defined precisely. It is not without reason that the French philosopher Jean Baudrillard stated that we are no longer living in the age of reference, but in the age of referendum, because of this asking. The whole program is structured according to this logic of cause and effect. Everything that happens on the side of the dynamics in simulations follows this scheme. Everything not following this scheme is not part of the simulation. The decision tree that I show you on the left side represents, on a higher symbolic order, how a computer has to proceed as soon as the so-called artificial intelligence, I'm going to show you in a couple of minutes, thus a creature being part of the simulation does not know what to do. So then this module of trial and error is activated. And I know that you are familiar with how this is working, but it's a little bit cryptical, so I looked for in the internet for another way. You might be able, or you might be familiar with that, because it was designed in German, but I don't know in how far you can read that, actually. So this functions that way, that Here we have, there is a problem. Does everything work anyway? Yes, leave it at that, and there is no problem. Or, does everybody function? No. Have you messed around with it? Yes. Does somebody know? No. Keep it to yourself, and there is no problem. Or, have you messed around with it? No. Are you responsible for it? Yes. You have a problem. Can you blame somebody else? Yes. So, no problem. So, of course, this is a joke. However, similarly, one would formalize and calculate these directives. These interrelations would be worked through during an execution of the program, and that is during the simulation. Here I show you a still of a simulation where this trial and error module is inserted. Psi is the machine creature, an artificial intelligence operating alone on an island and pursuing the aim of collecting so-called nucleotides. These are energy sources. However, at the same time, it has to make sure that it constantly provides itself with enough energy. The list on the right-hand side here is a kind of transcription of the decisions taken by the artificial life system that is more or less comprehensible for the humans. So I try to read out a sample for you. Which aim? Moving 2, 3, 2, action, checking it out, moving back, moving 2, 3, 1, action, checking it out, moving back, moving to rec 2, action, watering it, moving back, moving to dune 1, action, checking it out, picking nucleus. No look around, is there an automatism? No idea. Is there a plan? I plan now. What to do? Nothing comes to my mind. Let's try something, trial and error module. Moving to mountain 1, action, hammering, result mountain 1 broken. What is the main motif? Nucleo. Moving 2 and checking it out. 3, 2, 3, 1, rec 2, dune 1. Looking around, looking for aims, found nothing, no aim reached. Is there an automatism? Back association. Can we move back? We can. Action, moving back 1 step, which aim? And so on. So you see the same actions return again and without a long chain of causal relationships. However, this artificial life or artificial intelligence is learning and is optimizing its actions. On the right we see a somewhat different depiction, what should convey an impression of how the single neurons of a part of a brain of this artificial intelligence are connected with this curved line. Here, you see here cortex that represents, alludes something like a morphology, but the connected entities, neurons, are connected functionally. So it will soon become clear where the main differences between the two perspectives are. These differences make it necessary to define further level of forming because the system's perspective as such, as well as its adoptions in specific applications, is not yet visual and is not yet oriented towards a spectatorship. By the way, this is the reason why it was next to impossible to filter out the medium by just looking at the stills. The medium to be extracted from the simulations is not primarily or is not located in the visual cues, but in the kind of process. I would like to express my main hypothesis as follows. The first basic forming instance of a calculated dynamic of interactive real-time computer simulations can be described by the system's perspective. In this point, I totally agree also with the game designer Katie Sellen, for example. My statement can provoke several questions. First, to what extent can we speak of a kind of perspective in the face of computer simulations? Second, why systems perspective? What are the differences to the linear perspective? Third, does the first instance of forming mean that there are further ones? To approach these questions, let me remind us of a famous statement by the art historian Erwin Panofsky. I read only the last part. This is why it is essential to ask the artistic periods and regions not only whether they have perspective, but also which perspective they have. Today, I do not want to problematize Panofsky's statement about the linear perspective for which he was criticized. This quote should merely recall that there exists not only one perspective in history. From the many more I show you only a few. While the linear perspective is often linked to the idea of transparency, of looking through a window, the anamorphically distorted version is associated with the secret and the hidden. In this case, we need to place a conical or cylindrical mirror on this image in order to recognize the motif properly. The two now following newer developments are not broadly applied like the former ones, but represent inventions of individual artists and scientists, and they are probably used only by them. Here we see a water drop perspective invented by the Hungarian artist Tamás Walicki. The horizon is not a straight line anymore, but mutated into a sphere. In the center of reference for the representation of this spherical world is a child's head. In Walicki's animation, everything distorts according to this moving position. The beholder can witness this pictorial logic from outside. With their interactive application, the physicists Ute Kraus and Mark Borchertz from the University of Tübingen suggest a relativistic perspective. That is, how a small idyllic town, Tübingen of course, looks like if we are able to cycle through it with high velocities. The still I show you here represents a near speed of light situation. So the camera cyclist can look behind her, and due to the Doppler effect we would perceive other intensities and colors because the wavelength range shifts. So looking ahead we would see in infrared and looking back in ultraviolet. That is a little bit difficult to represent. In the following I will compare the system's perspective with the linear perspective. This already presumes that the first may legitimately be conceived as a perspective. I suggest the following aspects as contributing to a perspectivation in general: having a point of view, considering things in certain respects, considering only some aspects, leaving others apart, applying a set of rules that affect these aspects. The Encyclopedia Brockhaus offers us the following definition of simulation in a technical and scientific context. A simulation is the model-based depiction or reproduction of certain aspects of a given or a planned cybernetic system or process with a special focus on the temporal behavior. Systems in system theory consist of linked components. Simulations, as reproductions of systems, configure processes. However, they do not do it arbitrarily, but according to defined restrictions that follow certain premises. These premises, in turn, are related to the fact that we see the depicted or the simulated as a system. Seeing something as a system already means a typical sort of structuring. This structure gives us the possibility of formatting the investigated thing in a way that it makes it compatible with the operational mode of simulations. Then we are mainly paying attention to the relations between the linked elements, to feedback mechanisms, to oscillations, influences, input, output, mechanisms, and we are of course omitting a lot of other aspects. With relation to the conceptualization, the system's perspective as well as the linear perspective concerns the whole complex of the depicted, however only in some respects, while the linear perspective organizes spatial relations. The system's perspective is primarily related to temporal phenomena. In the case at hand, that is with computer simulations, it affects the forming of processes. Thus, these two perspectives control separated domains. They do not interfere and they therefore can be combined without problems. Both perspectives can be understood as mediums of expression and composition that operate in a calculus-based terms and offer a framework wherein images can be formulated. Both serve as a way to see a segment of reality in a specific manner, and they are at the same time attempts to deal with them in a symbolic way. They are different kinds of abstractions, culturally determined as well as normative. the geometric as well as systemic reduction of the everyday complexity leads to inequalities of blind spots, of focus and distanciation in each case. Both perspectives are confronted with the same criticism. On the one hand, that they are suspected of not correctly reproducing the facts. On the other hand, they seem to favor a certain point of view. We should take notice of the fact that the broad applicability of both perspectives has its price, in that they premise the acceptance of certain axioms. So, for example, the differentiation between technical, psychological, and physiological facts is in existence for systems theory. And here I quote Pierre Lévy. For this theory, there is only one class of facts: the observable, describable, and communicable facts. End of quote. And also with the linear perspective, bodies and the spaces between them are subject to the same depiction principles, whereby body is conceived as something determined through its position in space and only through that. So I quote here the philosopher Sibylle Krämer: "Thus all bodies are treated in the same way. It does not matter if we deal with humans or things, with high rank or ordinary persons. The linear perspectival construction does not relate to the meaning of the represented. The geometry becomes a universal language of visual syntax that homogenizes what can appear through it in an image." End of quote. I would like to emphasize my most important idea once more. While the linear perspective organizes bodies in space, in the system's perspective, the ambition to depict shifts from the outer appearance and extension of objects to the registration of their network of relations and patterns of behavior in the temporal process. So here I try to say what the perspectives organize. I mentioned the conclusion already. As media of construction, each perspective preforms the images to the extent that it defines which aspects are shown and how they are shown in principle. If we ask ourselves once again why it could be interesting to gain insight into the underlying level of images, we can say, at least for the real-time simulations, firstly, we gain an argumentative handle in order to draw useful demarcations to other modes of depiction, for example, to video disc works that might also provide interactivity, or to animations. Secondly, when determining the simulation's area of design responsibility, some largely unconsidered or not yet considered enough areas of study pop up, for example, the relationship between the simulations and the visual imagery. Generally speaking, space does not belong to the simulation's domain. In my view, this means that time, namely simulation, and space, iconization, enter a negotiation. Specifying the relationship between the simulation results and their iconization has to enjoy great interest with respect of knowledge projection. Why? Because this makes clear which design moment contributes to which degree to which expression. The visual output adds many nuances, even if the developers pursue the aim of remaining true to numerical data. So thus we can question the assumption claiming that the visualizations do not affect the calculated propositions. Often the visual and auditive level are regarded as useful but servile instances, and consequently they are not examined seriously enough. Then looking for the rules allows for judging the deviations. And most of the time these deviations are significant because it means that there was a conscious decision to depart from the default matrix. And furthermore, we can find various instances of forming. And here we come back to the third question expressed before, namely whether there exists other forming levels beside the basic and general perspectivation. In my view, we have several more. Here I show you a cascade of nested moments where issues of construction are decided. The system's perspective is framed by the digital computer in general, as are the computer simulations. The nesting is based on Luhmann's idea that media are form latencies, and as soon as a work is made, the medium is put into a concretization, into a form, which on another level can be regarded as medium again, that is collapsed into a next concretization, and so on, until the piece is completely finished. When looking at the sketch in my presentation today, I proposed some thoughts only for the outer frame. In order to analyze a single simulation in detail, this whole cascade would have to come into play. What becomes equally clear is that in designing such a simulation, many competences are assembled. Perhaps we would speak of synchronous collaborations where people are directly working together, and diachronic collaborations where designers build on something already developed by others. So thank you very much for your kind attention and patience, and I'm looking forward to the discussion.